When everyone first started talking about the cloud, it sounded as if the pendulum might be swinging back towards a client-server situation, with the cloud being the server to a worldwide population of relatively thin clients. Big cloud providers encouraged that model. Give us your data and we'll sell you access to our services. But that one cloud has evolved from being a single entity to a broad concept. A concept that included private as well as public clouds, and then the inevitable hybrid clouds incorporating both public and private clouds. Now we have multi-cloud. Is this just a new name for a hybrid cloud? Not exactly. A multi-cloud means relying on several cloud services from several vendors for business purposes. But the two are not distinct. For example, Dell EMC Cloud Solutions offers to transform IT by leveraging a multi-cloud approach spanning a variety of public, private, and hybrid resources. And IBM's Multicloud Solutions page says, multi-cloud is a cloud adoption strategy that embraces a mix of cloud models, public, dedicated, private, managed, to best meet unique business, application, and workload requirements. To find out more, we'll be hearing from 5 senior industry representatives, starting with Luc-Valente, Vice President from Cisco's Cloud Platforms and Solutions Group.
Good morning, Valente. I run the Cloud Platform and Solutions Group portfolio from a product management standpoint.
I'm Mansour, Karam, the CEO and founder of Apstra. Apstra builds software that automates and abstracts out infrastructure to deliver a service layer to business applications. And it does that across the entire life cycle, day 0, day 1, day 2+, and across all types of network services.
Galeal, Zino, CEO of NetFoundry. We connect applications wherever they are.
Michael Segal, responsible for strategic alliances at NetScout. And NetScout assures performance and security of services for the largest enterprises and service providers in the world. Basically, we look at traffic data and convert it into actionable insight regarding key performance indicators for both service performance and security.
John Mittelhauser. I run the cloud native group at Oracle Cloud, building kind of infrastructure for modern applications, Kubernetes, et cetera. I'm also the representative for Oracle at the Cloud Native Computing Foundation.
We now invite Peter Burris, Chief Research Officer and General Manager, Wikibon, to introduce the discussion, keeping it in the context of business aims and outcomes.
The fundamental business objective is to start using data as an asset. The difference between business and digital business is really simple. It's the role that data plays within the business. A business that treats data as an asset institutionalizes its work differently, it establishes value propositions differently, it sets up different types of engagement models. And in many respects, fundamentally, digital business is about how you're going to put data to work differently. And that has enormous security implications, it has enormous questions about fidelity. And one point to make here is that the notion of data as a new oil in many respects, almost respects, is a misnomer. Data is easily copied, it's easily shared, it's easily corrupted. It does not follow the laws of scarcity. And that has enormous implications, certainly for all the vendors on the panel and virtually every enterprise on the planet. One of the tests, ultimately, of whether or not you can conduct or undertake a digital problem is what the degree of the relationship between the fidelity of the data and the fidelity of the action that you're trying to undertake. And today it's relatively weak in many circumstances. We're applying data to turn products into services. Specifically, data allows us to remove something known as asset specificities. And asset specificity is the degree to which an asset is limited in how it can be applied to different uses. By making things more programmable, more observable, more visible, more optimizable, it means that we can apply the rest of the business's assets to a lot of different activities. And that's especially pertinent when we come to the notion of a product versus a service. Increasingly, people and businesses want to purchase services, the outcomes that the assets provide, more than the assets themselves. And in very real respects, cloud fundamentally is the process of this move from products to services in the tech industry itself. And so as you think about what's happening, in many respects, what a occurs in the tech industry is a test and a precursor to much of what's going to happen in business overall. But very importantly, while we like to think of this as a major change, and it certainly is, this is a major period of transformation, no question, the cloud is part of some ongoing technology trends. Historically, there have been three ways to improve the performance of computing. You can improve it through technology, specifically better silicon, different geometries, et cetera. You can improve it through instructions and architecture, or you can improve it through parallelism. Dennard scaling and other limits on the technology means we're going to have to find new ways of improving the performance of computing. And that's why you see on the architecture front things like GPUs being utilized, greater utilization of ARM processors, et cetera, that lower the cost of each transistor and apply them to do more and interesting kinds of work. But the real change, the real drive to new levels of performance in computing is through parallelism. And fundamentally what the cloud is, it's an architecture for simpler, powerful, distributed computing. That's really the test of all this. It's not a strategy for centralizing computing. So it's part of the ongoing natural process of the computing industry that's intended to make better use of parallel processing as a way of dramatically increasing the performance of computing, and so that we can apply it to increasingly rich and complex problems. Now, that last point is really important, and I want to amplify it before we get into the questions. Historically, for the past 5 or 6 or 8 years, largely driven by the marketing of some very, very strong companies, very impressive companies, we have thought of the cloud as we're going to move our data into the public cloud, and we're going to get access to a lot of services. The quid pro quo is give me your data, which locks you in, and then we'll give you access to these interesting services. But what enterprises want, and what the natural attributes of data requires, is that we try to keep our data in place where the actions, where it's collected, where the action is going to take place, where it's most secure, where intellectual protection or intellectual property protections are easiest to administer, and we want to move cloud services to the data. So this is not about moving data into the cloud, this is about moving the cloud and cloud services to the data. And the natural organization of the cloud in 10 years is going to reflect a natural organization of data, whether it's at the edge, whether it's in the core, or whether it's in public cloud attributes. Now, that raises, I don't know, somewhere between 3 or 4 million questions, I think we could probably agree, but I want to focus on 3. The first one is, if in fact this, and by the way, my comments are not necessarily everybody's comments. This is not an agreement with me, and all the panelists can feel free to disagree with me. But when we start here, what are the impacts of data emerging as a or the primary asset? And JL, why don't we start with you? What is this, when we think about data and the idea of greater data distribution, what are some of the impacts of how IT is going to think about itself, organize itself, imagine its mission as the notion of data as an asset is elevated?
So, to your point, in addition, so it's not just the data. I think the currency is really the applications for many people.
Well, applications are data, software, and it's part of the
yeah, I can say that, but I think for often people would think of data really about the attributes around, clearly the different objects or the different assets that you're using. The key point is, so first, the bigger the data, the more solid it became. So data was liquid for a while. Back to your point about moving the data. If you take a terabyte and you try to move it to the cloud from a private cloud, you can do it. It's still going to take time and cost you money. But if you take an exabyte, which obviously today we would generate the volume of data, it's almost impossible. It would cost $30 million actually to egress that to a public cloud. So to your point is, what we see a tiering of environment from private environments from customers to whether actually it's on-prem or hosted by partners, whether it's colocation or hosting. to the edge. And obviously, a very big explosion of the edge, ultimately all the way to a device. So that actually creates, in terms of the access to the data, both from a networking and from a security standpoint, a lot of new characteristics, challenges, and complexity. Although we try to make it simple, it becomes pretty complex in management.
John?
Oh, I was basically nodding in agreement that a lot of it is the connectivity. I mean, one of the main things, we obviously sell to a different type of customer than our competitors like AWS that are selling to kind of the long tail. We're very focused on Fortune 1000, government entities, et cetera. And a lot of our value add is fast connect between our data centers, customer data centers. The data can live in either place, but I agree that it's the key asset. I mean, I had old startup mentors, keep the main thing the main thing. For most companies in the world, their data is their asset. It's not the software. I mean, sometimes the software accesses the data. I mean, here in Silicon Valley, the software is often the value, but outside of Silicon Valley, it's the data or what they do with the data, which software helps with.
Yeah, let me ask you guys a question related to this. We've seen multiple generations of network formation in the industry. We've seen the idea of devices being the primary thing to network, then pages being the primary thing to network, Facebook and others bought in identity. Are we moving to a world where service and data becomes a primary citizen within networking? What do you think, Ellen?
Yeah, the application or the data is the new edge. And agree with John, connectivity, networking is at the forefront of it. And if you think about it, all networking to date has been built on a very different assumption, where you connect sites together. And again, whether that's public cloud, private cloud, branch offices, data centers, it doesn't matter. Those networks were built to connect sites. Now that the application is the new edge and data is everywhere, we actually need to reinvent networking and the ecosystems around networking to match that new reality.
So it's not necessarily although data has physical attributes, it's not necessarily the physical device that we're thinking about, it's actually the asset that is the data, that is the service that presents to the data. Michael, what about you?
Yeah, so I want to take a step back before taking 2 steps forward. So let's think of, what does data mean from business perspective? So what do you do with data, right? So obviously you use data to train machines. You use data mining in warehouses and data lakes to create business decisions and make them smarter and more relevant to your environment, right? You analyze your environment. So what this means is that many of the aspects related to data mean that they need to be analyzed in real time. And this kind of alludes to the fact that edge computing becomes very important. The data needs to be close to where it's being analyzed and where it provides insight in many examples in real time. Beyond that, if you think of data, data is only as valuable as the intelligence that you can derive from it. And in order to derive this intelligence, you need to process the data. And this is where services and applications, based on your question, Peter, are intertwined with data. The value at the end of the day to enterprises is what the intelligence that they can glean, how they can accelerate their digital transformation and make it more impactful and more relevant to their business. So from that perspective, I think that definitely IT needs to gain visibility, and Paul Krause, my colleague from NetScout, previously spoke about the ability to understand actually what are your assets, and network is a key component of any assets that you have, because in this distributed environment, we're talking about the edge and data being at the edge, you need to be able to communicate every action and transaction in a timely fashion, and that's the importance of networks.
So if we think about this, one of the things that I find interesting is, in many respects, I worked in Roger Shank's lab as an undergraduate a million years ago. And many of the algorithms that are currently being used in machine learning, deep learning, AI, were understood at that time. In many respects, the fact that we are now able to build these very enormous parallel machines utilizing GPUs and related technologies means that for the first time we can actually apply some of those algorithms. It doesn't mean that it's all magic. There are certainly limits. But obviously this is enormous impacts when we think about data and we think about data as a primary citizen within a networking world. It means we have to start, as we just talked about, forming networks differently. What do you think about that, Mansour?
Yeah, absolutely. In a world where we're distributing data, networking becomes a critical foundation. And in fact, the importance of networking is as high as ever. I think it's really an exciting time to be in networking, given the complexities. When you think of it, it's about connectivity. You want to be able to connect workloads that are processing all of this data, but also how do you describe security policies and then enforce them in this distributed environment. Compliance, how do you meet compliance requirements, and certainly the network also takes a central role. And finally, it's all about performance. It's about delivering applications with certain SLAs, and ultimately the network itself is critical to making it all happen. And so I think one consequence of all this is that managing networks like one did before just no longer works. You can't manage networks manually. You can't manage networks by configuring devices by hand. It has to be done through software. It has to be done through automation, through powerful automation. You have to have the ability to abstract out all of those network services across all of those domains. And you have to have the ability to operate these networks, enforce those policies, set these configurations, and verify them remotely. So you can't have humans essentially do this in every location where the data resides.
So Mansour just started to segue into the next question, which is what is the relationship between multi-cloud and networking? And JL, I want to give you an opportunity to build on what Mansour talked about, because in many respects, the cloud is better thought of as a way of building networked, highly distributed, highly parallel applications. What do you think about that?
So enterprises, to the point here, enterprises are picking up a lot of different cloud environments. And again, as we stated earlier, we talk about multi-cloud. We talk about multi-cloud, hybrid cloud, which is really a combination of private cloud and obviously a number of public clouds in the form of infrastructure as a service, platform as a service, and SaaS. Certainly, Oracle is a very good example of offering all of those. At the same time, what's happening is, back to the data and back to the applications to process those data is I think IDC said very recently, 50% of new applications will actually pop up in the next 2 years. And back to the services is, how do you bring the new services? Well, you need to bring obviously a combination of applications and data. And those new applications are container, a lot of them will be microservice, containerized based. There's a churn of the current portfolio. There is a lot of new development taking place. So how do you leverage actually those different clouds in a secure way with very high connectivity? How do you leverage new technology like service mesh, which is at the end of the day, the key piece here, and that's what it goes back to application, is DevOps or DevSecOps, if we call it, is those applications that we develop, what level of understanding of the networking do they have, and vice versa. And I think back to your point is, because of the new, clearly, environment that is being built, we have to fundamentally completely change the way we do networking. And that's where I think container networking, container security is going to push into new areas where we can do bare metal containers and VM, because they're going to be with us for a very long time in a different way that is abstracted both at layer 7, layer 4, and underneath, both underlay and overlay. That gets back to what you guys do as well.
Just building on what both JL and Mansour were going over. the importance of the cloud is not where the data is, right? It's how it's managed. It's the agility. It's the automation, DevOps, DevSecOps. It's the way that we can manage that data with agility and automation. Once that moves to the edge, and we're getting there, right? Once we can manage the edge with that same level of agility and automation, then all of a sudden the data and the applications will exist wherever they are best put. And the challenge then becomes, how do we network all that together? And how do we network all that together without creating structures that take away from that agility and automation? So for example, with cloud, fairly centralized, right? I can run some huge MPLS circuits up to a few clouds and call it a day. Might cost me an arm and a leg, I might not like it, but I can call it a day. Good luck trying to do that with edge distributed applications and data. Just too many boxes and wires. So that will be the challenge going forward, is how we actually build new networking for that new kind of edge distributed reality.
Well, we talk with a bunch of different companies who talk about doing multi-cloud, and it's been pointed out. I mean, I think we all fall in the trap of trying to oversimplify here. There's, you talked about net new, and I run the group that does Kubernetes, so I'm a big fan of net new and container. But we really talk to three different, enterprise customers tend to have people in all three of these camps. They have existing legacy applications. They're looking at either lift and shift or just continuing to run in their existing environment. They have kind of re-architecture applications. They want to modernize an application. Docker calls this modernizing traditional applications. And then there's net new. I think the challenge is different across all those three. I'm kind of giving a long-winded answer here, but multi-cloud is similar. I was talking to a bank in Australia, and they actually have regulatory requirements that they don't single vendor anything, including their cloud. So we were just about to announce our partnership with Azure, with Microsoft, and I pre-briefed them on that, and that got them very excited because they could then run multi-cloud across Azure and Oracle Cloud. That's a form of multi-cloud. Other forms of multi-cloud are basically just distributed endpoints, forms of edge as well. They are all different networking challenges. That's why these guys have very successful businesses next to me doing networking, because this is a complicated endeavor.
Yeah, extremely complicated. And in many respects, this relationship is going to evolve over the next few years. I think you'd all agree that this is going to be one of the most fertile areas of invention and innovation, is to further drive this relationship. Michael, did you want to say something?
Yeah, absolutely. So in terms of the architecture of a multi-cloud and what it encompasses, I think of multi-cloud starting in the data center. And we mentioned microservices, so there's a lot of server farms and a lot of east-west traffic and containers and virtualized environments in the data center itself. Then you extend it, not necessarily immediately to the public cloud, in some cases to private clouds in colos, such as Equinix. And then you can have several different public cloud providers, Oracle, AWS, Microsoft Azure. And in this environment, if you think about the complexities associated with connecting everything, many of them are edge computing environments. So from networking perspective, it needs to be more responsive, higher throughput, especially over the WAN, and more automation. So for automation, for example, if we talk about SDN, software-defined networking, and products such as Cisco's ACI and VMware's NSX, NSXT also extends itself to the public cloud, and that's another way to incorporate both networking and multi-cloud environments. From NetScout specific perspective, I just want to mention that besides the fact that we have very tight integration with VMware and NSX to monitor all this east-west traffic and north-south traffic, it extends additional challenges and also opportunities to instrument pervasively and gain visibility end-to-end into services that traverse this very complex multi-cloud environment.
One comment I want to make here before we go on is that the very nature of data, which allows it to be copied and shared very easily, means security plays an increasing role in how you define or how you create data and imbue it with asset attributes. And I think that's something that we all have to remember, is what will be the role of security in actually ensuring that I get value out of data and other people don't if I don't want them to. The second thing is that I'm talking to a lot of clients that are thinking about how they're going to roll together their SOC and NOC, their Security Operations Center, as well as their Network Operations Center. And I think there's going to be a lot of talk in the next few years for what I'll call a multi-cloud operations center, which is a maturing of that process so that we can actually look at these distributed assets from a relatively consistent point of view. Now, one of the reasons why that becomes so important leads to the next question. And Mansour, I'm going to start with you. We keep talking about this data explosion, and both JL and Mansour brought this up. But what about this coming software explosion? As we move into a realm where these distributed services are access to both applications and data, there's going to be an enormous explosion in the amount of software that's being generated over the next few years. Mansour, what's that going to mean?
Absolutely. In fact, software takes center stage because when you think of distributed environments that are scaling continuously, it becomes impossible to do things without software. Automation means software. Abstractions means software. You're going to define things in software, enforce policies in software, and at the core of this software is state. Ultimately, you need to have the ability to have visibility into what's going on, gather all this state, have the ability to represent all the relationships between all those layers, all those domains, and have the ability to verify that indeed that's the only way you can verify and you can that indeed your infrastructure is secure, indeed your applications are working well, indeed you're delivering on compliance and performance. So well-designed software, best-of-breed software takes a central stage, and this is why at Apstra, with intent-based networking, we like to think of a software-first approach. Ultimately, a lot of organizations in the past have partnered first strategically with hardware vendors, because when you think of infrastructure, you think hardware, you think I need to buy boxes, and so that should be my strategic partner, and then once I decide my hardware, then I can go on and decide on what software to use. But in a software-first world, this approach is extremely restrictive because ultimately you are limited to those software offerings that particular hardware vendor supports. Rather, what we're seeing organizations do in this new world is start by partnering strategically with software vendors so that they define this layer of software first, this service layer. And then once they've done that, then of course hardware is important and they can go on and shop for the hardware that specifically meets their needs.
So on this explosion of software, one of the key areas that is also becoming a complexity to that point is the fact that those applications are composable. And many applications more and more have dependencies upon other components or other applications. And to your point, as you actually distribute them more and more to the edge, one of the key complexities that we see for customers first is even understanding the dependencies between the different parts and the level of connectivity back to the security aspect as well, then how actually you segment or micro-segment those elements. So the level of understanding, visibility, encryption end-to-end, which is very critical and not always there today when you start stitching all of those elements become challenges.
And that has a major impact on ultimately the fidelity of the representation of the digital with the real, doesn't it?
Absolutely.
Yeah, similar thoughts here. So with regards to software explosion, I don't know, 10 years ago, 15 years ago, most of our businesses used software, right? We use software within our businesses. Increasingly, our businesses are software, right? More specifically, they're connected software. You see businesses, you see ecosystems, you see entire supply chains that are emerging on the assumption of pervasive, secure, reliable connectivity and networking. That to me is what's really interesting about the software explosion. And companies like Apstra, like Mansour, with intent-based networking in the data center, they've done a lot of this automation and agility. It's fantastic. And in fact, I think it's the blueprint for what we will see now extend out of the data center and go literally to the edge.
I think the only thing I would add, I entirely agree about sort of the growth of microservices, the growth of sort of not parallelism, but breaking things into chunks, which is a form of parallelism, but means something different usually. I think what's missing to do a lot of what we're talking about is not just the networking, but is the standards around things like identity and security and some of the others. Identity is one of the keys because of authenticity, et cetera. So, what we want is that software explosion to work together. So there's obviously layers where there's some standardization, either de facto or formal. Kubernetes has kind of won the battle for what the storm would be. But I do think there's some standardization that we all have to agree on as kind of major cloud vendors around some of these other things. That in terms of functions as a service, there was an effort for cloud events to be defined, and that was adopted by all the major cloud providers. So, Amazon, Microsoft, Google, us. I'd like to see more of that around identity. Our agreement with Microsoft was to work together on identity, but that's really only 2 of the vendors, right? It would solve a lot of these other issues in terms of composing things.
But John, talk about that issue of identity, because I noted that we've seen multiple areas of network formation. Identity is more than a device. It's even more than an individual. It's becoming assumed that it's going to be part of a service. Are we actually also going to get to the world where data has an identity? That's the direction we're taking?
Yeah, I mean,
Are we going to see DNS extended to include data?
I don't know about DNS as a protocol because it's got some issues, but yes, you need some forms of, within our cloud, we talk about resource principles, and these are cryptographically strong, identifiers for a piece of information. Now, we also have identity principles which map to a human, but we have resource principles for a security policy, for example. So a security policy can be signed and identified as the security policy for a network switch. And that is again, we've developed our own way. Some other people, we've tried to adopt things. The more we can standardize those things as we come up with these connected, private, public, edge centers, it's going to make those of us who are more of the software side than the networking side, it's going to make our lives a lot easier.
So I think that software explosion is definitely coming our way, and it is very closely coupled with business agility. So if you think as software as the one key component that galvanizes and facilitates business agility, then the transition to microservices, which is aligned with agile development methodology, right? Each engineer kind of develops its own microservice, and then they work more effectively together. So the complexity of the software is also going to increase. So if you think of that complexity as being n, and the data explosion complexity being another n, so we have n square complexity, and I think this creates a paradigm shift in terms of the way that we should think about service chaining. If the traditional kind of service chaining, which is similar to the way you would develop your data center, for example, let's say you have a firewall, you have a router, you have IDS, you have load balancer. I think that visibility, and Mansour referred to this as well, visibility is going to become an imperative in any service chain that is developed in the modern environment that is multi-cloud and networking driven.
Just to summarize a couple things really quickly. Number one, the cloud is a way, think about the cloud as a way of distributing work and not centralizing it. Number two, the data is going to emerge with the caveats that we identified here as a basis for imagining how that distribution of resources will be set up over time. The network is the centerpiece of that process, and as a consequence of the way that we end up thinking about things, there's going to be an enormous amount of software, and how that software ends up distributed and how those services associated with those software are proffered for commercial and other uses, in many respects, going to define the scope and complexity of the multi-cloud moving forward.
Thank you, Mansour Karam from Apstra, Luc-Valente from Cisco, Galeal Zino from NetFoundry, Michael Segal from NetScout, and John Mittelhauser from Oracle. And special thanks to Peter Burris from Wikibon for guiding this discussion across this complex and very relevant topic. Thanks for listening to this NetEvents podcast. A full transcript is available from www.netevents.org.